Kita belajar tentang reaksi reduksi oksidasi atau reaksi redoks. Kita ingin melihat atom yang mengalami oksidasi dan atom yang mengalami reduksi pada tiga reaksi, yaitu reaksi pembakaran gas metana, reaksi pembentukan air, dan reaksi pembentukan besi 20. Mari kita lihat video yang kami ambil dari Kanada. Lihat.
We now know what an oxidation state or an oxidation number is and what it means when things are oxidized or reduced. And let's see how that actually happens in reactions. So what we're going to study in this video is oxidation slash reduction reactions. And all that is a reaction where somebody's being oxidized, which means that electrons are being taken away from them, and someone's being reduced, which means that they're being handed electrons, or they're taking electrons away from someone else. And sometimes this has been termed, because you have the RED in reduction, and you have the ox in oxidation, and they switch them around, and they call this a redox reaction, which sounds like a very fancy chemistry term, but it just means a reaction where something is getting oxidized, and if something is getting oxidized, something else is getting reduced. So let's study a couple of them. So right here I actually have combustion. This is actually methane. So you know, methane is a fuel. It can be used to, you can make a motor powered on methane right there. It's a hydrocarbon. Most fuels that we use are hydrocarbons, which just mean carbons bonded in a bunch of different ways to a bunch of hydrogens. And if you add a bunch of enough heat for the reaction to happen, so it's activation energy, you have to put it in there, with some oxygen around, it's going to combust, and it's going to produce carbon dioxide and water, and I didn't put it here, and even more heat than you put into it. So it's actually an exothermic reaction. It produces more heat than you put into it. And I'll do a lot more of that in future videos on endothermic and exothermic reactions. But anyway, we care about the oxidation and the reduction. So let's see if anyone's getting oxidized or anyone is getting reduced here. So let's look at their oxidation numbers or their states. Here, carbon is bonded to 4 hydrogens. Who's giving, who's taking? So carbon, let's go to our periodic table. Carbon is here. Hydrogen is here. Carbon is more electronegative. It's almost, it's adjacent to kind of the three musketeers of electronegativity. These guys are the most electronegative. We always ignore the halogens because they pretty much, not the halogens, sorry, the noble gases, because they pretty much don't react at all. They're always happy with their 8 valence electrons. These guys love to get electrons. They're small molecules. Their outermost shell is close to the nucleus, and they're so close to becoming noble that they just love hogging electrons. Carbon's almost there. Carbon's much further to the right on the periodic table than the hydrogen. So if you have carbon bonding with hydrogen, carbon is going to be the electron hog. So in this situation, let's go down here. So if carbon's the electron hog and hydrogen is having its electrons taken away from it, remember this is all kind of hypothetical. It's more partial is the reality. But if you had to pick or choose, hydrogen's going to lose electron each. So it's going to have an oxidation state of +1 for each hydrogen. You have 4 hydrogens each giving up an electron. So the carbon must be taking 4 electrons. So its oxidation number is -4. It's taken 4 electrons. So its charge will go down by 4. So that's why it's negative. Fair enough. What's the oxidation state of this oxygen right there? Well, it's just bonded to itself. There's no reason to believe that one oxygen should be able to take any electrons from another oxygen. So it has a 0 oxidation state. It's not hogging more than its fair share of electrons that it was essentially kind of born with. Now, after the combustion occurs, what are the oxidation numbers? Well, I have oxygen bonded with carbon. 2 oxygens bonded with carbon. Now, we know oxidation was to some degree named after oxygen. It is one of the most electronegative. Almost anything bonded with oxygen is going to be giving up its electrons. We also know that oxygen likes to take 2 electrons, because if it takes 2 electrons, then it starts having if it takes 1, it gets here, 2, it gets here. It has a configuration like it has 8 valence electrons. So its typical oxidation number is -2. So carbon in this situation, each oxygen is going to have a -2 oxidation number. the carbon dioxide molecule is neutral. So everything has to add up to 0. The oxygens, you have 2 of them, each of them with a -2 oxidation number, so that's -4. So carbon must be +4. +4. Which means that it has given up 4 electrons, right? And really it only has 4 electrons to give up. It has 1, 2, 3, 4 valence electrons in its second shell, which is its reactive shell. So its oxidation number is +4. Now let's look at the water. We've done that a bunch. When the hydrogens each give up an electron, so they have an oxidation number of 1. Each oxygen takes 2 electrons. There's only one of them, so it's -2. So what's going on here? What's getting oxidized? What's getting reduced? You have the carbon. It went from an oxidation number of -4 to an oxidation number of +4. So let me just draw what's happening to the carbon. Carbon goes from -4, which means it's hogging 4 electrons, to a situation where it's having 4 electrons being hogged from it. It's kind of giving away 4 electrons. So someplace in this process, this guy must have given away 8 electrons. This is a difference of 8 electrons. So plus 8 electrons. So what's happened to carbon? Carbon has it been oxidized or reduced? Its charge has gone up, so it hasn't been reduced. Or the other way is that you can say its electrons have been taken away from it, so it has been oxidized. Oxidized. Carbon has oxidized. Now let's look at the oxygen itself. Oxygen, over here you have 4 oxygen molecules. I'll just write 4 oxygen molecules here. And they all have an oxidation state of 0. They're from an oxidation number point of view, they're neutral. And on this side, we have 2, and then we have 4 oxygen molecules. And what's their oxidation state? They're all -2. They're all -2. So oxygen each of these oxygens must have gained an electron. So actually, let me rewrite this reaction. Let me erase a little bit of it. So each of these, actually even better, let me just move this over. Nope. Let me move it over. There you go. And I can move that over. There you go. And let me fill in that just so aesthetically it's pleasing. There you go. All right. So we have 4 oxygens with a 0 oxidation state turning into 4 oxygens with a -2 oxidation state. So each of these 4 oxygens took 2 electrons. There's 4 of them. So we must have gained 8 electrons. So what happened to oxygen? Its oxidation state went down, or its hypothetical charge went down, or it was reduced. Its charge was reduced. So this is reduced. Oxygen was reduced. What was it reduced by? It was reduced by the carbon. What was the carbon oxidized by? It was oxidized by the oxygen, which oxygen tends to do. It tends to oxidize things. What is the oxidizing agent? What's the thing that did the oxidizing? So the oxygen is the oxidizing agent. What is the reducing agent? What's the thing that did the reducing? It's the reducing agent, is the carbon. Reducing agent. So you see, in this redox reaction, carbon was oxidized. It gave away 8 electrons from this state to that state, hypothetically. And oxygen was reduced. Its charge was reduced by a total of 8 electrons, but 2 for each oxygen. And so its oxidation number went down. Let's do a couple more. And each of these things I wrote, just to kind of do a side note, this is called a half reaction, because I'm writing just what happened to the carbon. And here I'm writing just what happened to the oxygen. And I did ignore something. I did ignore the hydrogen. And I encourage you to do something like this with the hydrogen. But you'll see that hydrogen was neither oxidized or reduced. On both sides of this equation, all of the hydrogens had a +1 oxidation state. Let's do another one. Here I have another combustion situation. This is what happened to the Hindenburg. They filled a balloon full with hydrogen because they wanted it to float, because hydrogen is a very light gas. Unfortunately, there must have been a spark and in the presence of oxygen, and it combusted. And actually, this is what is used for rocket fuel as well. If you have liquid hydrogen and actually, I don't think they have liquid hydrogen. Well, I don't know enough about rocket science. I'll have to do another video on that in the future. But let's look at the oxidation states. What's the oxidation state of hydrogen here in its elemental form? It's 0. Two hydrogens bonded to each other. No reason why they should hog or be hogged by another hydrogen. Two oxygen molecules or atoms bonded to each other. Once again, 0 oxidation state. Once they combust and form water, what's their oxidation states? We've done this multiple times. The oxygen has a -2 oxidation state. Each hydrogen has a +1. So let's write the half reactions. We have 2 hydrogens that are just happy as they are, neutral state, and they end up being, same thing. 2 H2s, or we could have written 4 hydrogens, either way. They turn into 2 hydrogens, 2 hydrogen molecules, as there's actually 4 hydrogen atoms, with a +1 oxidation state. So they must have each given away 1 electron. Now, how many total hydrogens are there? There are 4. So we must have given away 4 electrons, plus 4 electrons. So this is a half reaction for hydrogen. Now, let's do the same thing for our oxygen. We have some oxygen here. On the left-hand side, it has a neutral oxidation state, and then it ends up with we end up with 2 oxygens on the right-hand side. I could write it, well, I'll write it like this, 2O, each with a -2 oxidation state. So each of these oxygens must have gotten 2 electrons. So it got 2 electrons each, or it gained 4 electrons. So what was oxidized? Oxidized means that something was electrons were taken away from you. The hydrogen was oxidized. This is oxidized. Oxidized by oxygen. What was reduced? The oxygen was reduced by the hydrogen. And if you actually add these two reactions up, if you make this the left-hand side of your equation, and you make this the right-hand side of your equation, that you could say, okay, let me remove the electrons from both sides, and you'll end up with your original reaction. And just to make sure our terminology is right, what's our oxidizing agent? It's the thing doing the oxidizing. It's the oxygen. What's our reducing agent? It's the hydrogen. Let's do one more. So here I have iron plus some hydrochloric acid. Let's say this is in an aqueous solution. And you end up with iron 2 chloride plus some hydrogen. So let's do some oxidation numbers, and I'll do it fast this time. Iron is just by itself. It's got a 0 oxidation state. Hydrogen with chloride. Chloride's a halogen. Halogen. These guys love to take electrons. They love to take 1 electron. They typically have a -1 oxidation state. So the chlorine is going to have -1. The hydrogen is going to be +1. Add them together, you get to a neutral compound. Fair enough. Now you go on this side. What is chlorine's oxidation state? Well, once again, it always likes to take 1 electron. So this is -1. But I have 2 chlorines here. This is a neutral compound. So the iron oxidation state must be +2. +2. What about the hydrogen? Now it's just in its elemental form. So it's going to be neutral. So it has a 0 oxidation state. So what was oxidized? Our iron went from neutral to having 2 electrons taken away from it, which may give it a positive charge. So plus 2 electrons got taken away. So this was oxidized. So this is oxidized. What about the hydrogen? The hydrogen went from 2 hydrogens with a +1 state, and essentially they went to 2 hydrogens with a neutral state. So 2 electrons must have been added to the hydrogens. 2 electrons were added. Their charge was reduced. So they were reduced. And what were they reduced by? They were reduced by the iron. What was the iron oxidized by? It was oxidized by the hydrogen. What about the chlorine? The chlorine has a -1 oxidation number here. It has a -1 oxidation number here. It was neutral relative to the redox reaction. Anyway, I think you get the point now, and you can do this with a bunch of reactions. But this will give you a little bit more insight of actually what's going on and who's gaining or losing electrons. And in the future, it'll also help us think about a lot of the structures of molecules. Anyway, see you in the next video.